Have you ever looked up at the sky and wondered how do airplanes even fly? Or why is the weather such a big deal in aviation? Well, the answer is simple. It all starts with the atmosphere. The atmosphere is this invisible layer of gases surrounding our planet. It's not just important for life, like giving us the oxygen we breathe, but it's also absolutely critical for flying. Without it, aircraft couldn't generate lift, engines wouldn't work, and well, aviation just wouldn't exist. In this video, we are going to break down the basics of the atmosphere and how it affects everything in aviation from engine performance to flight safety. So, what's the atmosphere made of? Mainly two gases, nitrogen, which makes up about 78%, oxygen around 21%, and the remaining 1%, that's a mix of gases like argon, carbon dioxide, and ozone. Now, this mix isn't always the same. It can actually change depending on where you are or how high you are. For airplanes, this composition matters a lot. Jet engines need oxygen to burn fuel, and air density affects things like lift, drag, and engine performance. As planes climb higher, the air gets thinner, meaning there is less oxygen. That's why high-altitude aircraft need pressurized cabins and super-efficient engine designs. Alright, let's take a quick journey upward through the 5 main layers of the atmosphere. Each one plays a role in aviation. Troposphere, 0 around 10 to 18 kilometers. This is where most of the action happens and where commercial planes usually fly. Temperature drops as we go up, about 6.5 degrees Celsius per kilometer. The air is dense, which helps generate lift. Most weather, clouds, rain, storms, all happen here. It goes up to 10 kilometers at the poles and about 18 kilometers at the equator. Stratosphere, 10 to 50 kilometers, just above the troposphere. Here, the temperature actually increases with altitude because of the ozone layer absorbing UV radiation. Most commercial jets cruise in the lower stratosphere, around 10 to 12 kilometers, to avoid turbulence and fly more efficiently. Mesosphere, 50 to 85 kilometers. It's super cold here. Temps can drop to minus 90 degrees Celsius. This is where meteors usually burn up, but no planes fly here. It's too high for jets and too low for satellites. Thermosphere, 85 to 600 kilometers. Super hot because it absorbs tons of solar radiation. This is where we get auroras and where the International Space Station orbits. Exosphere, above 600 kilometers. The final frontier. Space is right beyond this. The air here is incredibly thin, mostly hydrogen and helium. Most aircraft stick to the troposphere and the lower stratosphere. Why? Because that's where you get the best balance. Enough air to generate lift, not too much drag, and good engine performance. Understanding the atmosphere isn't just cool, it's essential. Whether you are a pilot, an engineer, or someone who just loves airplanes, knowing how this invisible blanket around our planet works makes flying even more fascinating.